Welcome to our video on the Wumpus World Problem in artificial intelligence. Today, we're going to explore what the Wumpus world is, why it's important in AI, and how it helps us understand intelligent agent behavior. Whether you're an AI enthusiast or just getting started, this video will help you understand one of the fundamental concepts in artificial intelligence. So, what is the Wumpus World Problem? The Wumpus world is a classic AI problem used to teach concepts in logic, reasoning, and decision-making. Imagine a grid-like cave environment filled with dangers, pits that the agent could fall into, and of course, the Wumpus, a monster that the agent must avoid. The agent, or AI, must navigate through this cave to find a piece of gold while avoiding the Wumpus and the pits. The Wumpus world is typically represented as a 4x4 grid, and the agent starts in the bottom left corner, unaware of the layout of the cave. The environment is partially observable, meaning that the agent doesn't have complete information about the world around it. Instead, it relies on sensory inputs. For example, if the agent detects a breeze, it knows there might be a pit nearby, and if it smells a stench, it knows the Wumpus could be close. The challenge for the agent is to use these clues to make logical inferences, decide on the safest path, and ultimately achieve its goal. The agent has to make decisions based on the limited information available, which is a core aspect of the Wumpus World Problem. The Wumpus World Problem is important in AI because it introduces concepts like knowledge representation, inference, and decision-making under uncertainty. It teaches us how to design intelligent agents that can act based on limited information, just like how autonomous vehicles must navigate without always knowing all the conditions ahead. The agent has to use logical reasoning to make decisions, balancing risks while trying to maximize rewards, such as finding the gold. This kind of decision-making is fundamental in AI, where agents often operate in environments that are uncertain and dynamic. To solve the Wumpus World Problem, AI uses different approaches, like propositional logic and rule-based systems. The agent builds a knowledge base, gathers information from its environment, and uses logical rules to draw conclusions. For example, if the agent detects a stench in a particular cell, it might conclude that the Wumpus is in an adjacent cell. This process of reasoning and updating beliefs helps the agent navigate effectively. The knowledge base is updated continuously as the agent moves through the grid, and new observations are integrated to refine the agent's understanding of the environment. One key approach to solving the Wumpus World Problem is to use propositional logic to create rules that guide the agent's actions. For instance, if the agent perceives a breeze in a cell, it can infer that at least one adjacent cell contains a pit. Similarly, if the agent perceives no breeze or stench, it can safely conclude that adjacent cells are free of dangers. By combining these rules, the agent can systematically explore the environment, making decisions that minimize risk. Another approach involves using search algorithms, such as depth-first search, DFS, or breadth-first search, BFS, to explore the cave. These algorithms help the agent find a path to the gold while avoiding hazards. In addition, heuristic-based methods like a search can be used to improve the efficiency of the search by prioritizing paths that are more likely to lead to success. These search techniques are essential in AI for solving problems that require finding optimal paths or solutions in complex environments. The Wumpus world also highlights how AI can deal with uncertainty. By using probabilistic methods, the agent can estimate the likelihood of dangers in different cells. For instance, if the agent has multiple possible locations for the Wumpus based on the stench signals, it can assign probabilities to each location and decide which path is safest. This way, even if it doesn't have complete information, it can still make educated guesses to proceed cautiously. Concepts like Bayesian networks and Markov decision processes are inspired by problems like Wumpus World, as they help agents make decisions in uncertain environments. These probabilistic models allow the agent to quantify uncertainty and make informed decisions even when the environment is not fully observable. The lessons learned from the Wumpus World Problem extend to real-world applications, such as robot navigation, game AI, and even decision-making in complex systems. For example, in robot navigation, a robot might need to navigate a partially known environment while avoiding obstacles and finding the most efficient route to its destination. The Wumpus World Problem provides a simplified framework for understanding how an agent can gather information, update its knowledge, and make decisions based on that knowledge. Game AI also uses similar techniques to create intelligent behaviors for non-player characters, allowing them to navigate game environments and respond to player actions. In addition to navigation, the Wumpus World Problem is relevant in fields like autonomous vehicles and drone technology. Autonomous vehicles must make real-time decisions based on incomplete information about road conditions, obstacles, and other vehicles. By using principles similar to those in the Wumpus world, these vehicles can infer the safest routes and actions to take, ensuring passenger safety. The ability to reason under uncertainty is a critical aspect of making AI systems robust and reliable in real-world scenarios. Let's also discuss the limitations and challenges of the Wumpus World Problem. While it provides a great foundation for understanding basic AI concepts, it is still a simplified representation of real-world environments. In real life, environments are often much more complex, with many more variables and unpredictable elements. Additionally, the Wumpus world assumes that the agent can always accurately perceive its environment, but in real-world applications, sensors can fail or provide noisy data. Despite these limitations, the Wumpus world remains a valuable teaching tool for introducing key AI concepts in a manageable way. To implement a Wumpus world agent, you can use programming languages like Python to create a simulated environment and design an agent that uses logic-based reasoning to navigate the grid. Tools like AI libraries and frameworks can help you build more sophisticated agents capable of handling larger, more complex versions of the Wumpus world. By experimenting with different algorithms and strategies, you can gain a deeper understanding of how intelligent agents operate and the challenges they face in uncertain environments. In conclusion, the Wumpus World Problem is a foundational concept in artificial intelligence, helping us understand how intelligent agents reason and make decisions under uncertainty. It shows us how AI can gather information, represent knowledge, and use logical inference to achieve its goals. The problem also serves as a stepping stone to more advanced AI topics, such as probabilistic reasoning, planning, and reinforcement learning. If you're learning AI, mastering the Wumpus world is a great way to understand the core principles of intelligent behavior and decision-making. Thank you for watching our introduction to the Wumpus World Problem in artificial intelligence. If you found this video helpful, please like, share, and subscribe for more AI content and tutorials. Let us know in the comments, what do you think about the Wumpus World Problem? Have you tried solving it yourself? And what other AI topics would you like us to cover in future videos? We'd love to hear your thoughts and suggestions.